CBE 3. We're halfway through the year, and we're about to take the third of 6 tests. But remember, test 6 is just questions from the other 5. So there are really only 5 tests, and then kind of the final, I guess you would call it. So we have a quadratic. We want to know, where is the vertex? In the past, we found the vertex using completing the square, which you don't want to do in this case, because there are fractions and there's a leading coefficient. It's just a mess. So the best way to find the vertex is the x coordinate is negative b over 2a. So in this case, the x coordinate would be the opposite of negative 4 over 3 divided by 2 times negative 2 over 3. Does everybody follow that? So the formula is negative b over 2a. B is negative 4/3, and a is negative 2/3. So I do the opposite of b, and then 2 times a. And if you look at this, we end up with 3 negatives. 3 negatives becomes a negative, right? So whatever my answer is, I'm going to put a negative on top. If I remember, it might freak out if you put the negative in the front. We'll try it, but I don't know. I can't remember. So the top is negative 4/3. The bottom is 4/3. So what is negative 4/3 over 4/3? It's just negative 1. What if it didn't cancel like that? How do you divide 2 fractions? You flip the bottom and multiply, and in that case, everything cancels and I get negative 1. So the x coordinate of the vertex is negative 1. How do I find the y coordinate? Just plug in negative 1. So we stick negative 1 in there and in there, and that gives me negative 2/3 plus 4/3 plus 1/6. So I'm going to change this to negative 6/3 and 8/3, negative 4/6 and 8/6. Negative 4 plus 8 is 4. 4 plus 1 is 5. So 5 over 6. Okay. Now it wants to know the x-intercepts. How are we going to find that? Oh, what did I do? Loading assignments. Let's go back to wherever we were. It's probably going to give me a different problem. Oh. Anyway, new problem. How do we find the x-intercepts? You can factor, you can use a quadratic formula, but the nice thing is, even if the equation is messy, I can multiply by anything I want without changing the roots. So the last one, I would have multiplied by negative 3 over 2, and then that would have killed the leading coefficient. Actually, we probably want to do, that wouldn't get rid of all the fractions. We probably would want to do negative 6 over 2. Well, just negative 6. And that would clear out all the fractions. What would I multiply this one by to clear out all the fractions? 3. Is multiplying by 3 going to change the graph? Yes. Will it change the roots? No. So don't multiply before you find the vertex, because multiplying will change the vertex, unless the vertex is a root. But multiplying will never change the roots. So we times everything by 3. We get x squared plus 8x plus 16. Is that going to factor? Two numbers that multiply to be 16 and add to be 8. 4 and 4. So we get x plus 4 and x plus 4. So my answers are -4 and -4. Okay, but how does it want us to present those answers? Okay, so if there's only one x-intercept, enter the same value into each box. If there is no x-intercept, enter NA into each box. And if one is bigger than the other, type the smallest one in first and the largest one in second. Okay. Number 2. Equation of a parabola. So the vertex form of a parabola is y equals a times x minus h squared plus k. Do I have that written anywhere in the room? Probably should put that somewhere. Okay. So hk is the vertex, and notice the inside is opposite, and the h is opposite, and the k is not. So this equation, the final equation, is going to be something times x minus 2 squared minus 3. All I need to do is figure out what the a value is, and I'll have the equation. All right. So I know that one of the x, y coordinates is 0, 2. So I can put 0 in there and 2 in there. And then I can put the 2 in there and the 3 in there. And then I'll have everything except a, and I can solve for a. So 2 equals a times 0 minus 2 squared minus 3. So that becomes 2 equals 4a minus 3. Add 3. I get 5. Divide by 4. So this is 5 over 4. Okay. What is the y coordinate? What is the y-intercept? What's the easiest way to find the y-intercept? Plug 0 in for x. So we stick a 0 in here, and I get 5 over 4 times -2 squared minus 3. This becomes -4, or +4, sorry. And the 4's cancel. 5 minus 3 is 2. So the y-intercept would be 2. Sorry, let me do that again. So I plug 0 in for x. So I get 5 over 4, and then 0 minus 2 squared minus 3. So this here is just -2 squared, which is 4. So 5 over 4 times 4 minus 3. 4's cancel, and I get 5 minus 3, which is 2. So I just plug in 0 for x, and then solve for y. Okay. Polynomial division, right? In descending order, where the polynomial has a numerator with a smaller power than the polynomial in the denominator. Okay. Notice, well, I guess we don't need to worry about it in this case. Can we use synthetic division here? No. Synthetic division only works when the denominator is linear. So we have to use the box. So x squared, 3x, 7. Put in the 3x to the 4th. Pull out an x squared. That creates 9x to the 3rd and 21x squared. Add a column. Those two need to add up to 0. So I need a negative 9x to the third. Pull out an x squared, negative 9x. This is negative 27x squared. And this one would be negative 63x. Okay. Those need to add up to 2. And right now they add up to negative 6. So I need to turn a negative 6 into a 2. So I add 8x squared, pull out an x squared, and I get plus x. Now anything beyond this will be a remainder. So that 8 creates a 24x and a 56. Oop, I covered that up. Sorry. Okay. These need to add to 80. And right now they add to negative 19. So I need 61 more. No. Yeah. Negative 61x. And then those need to add up to 90. And right now they add up to 56. So I need an additional 34. What do I do with my remainder? Plus negative 61x plus 34 over the original x squared plus 3x plus 7. Okay, now look at what the problem says, where a polynomial in descending powers plus a rational expression where the polynomial in the numerator has a smaller power than the polynomial in the denominator. That's just saying put your answer and then put your remainder in this form. The remainder will always be bottom heavy. Otherwise, it's not a remainder. It's like saying 37 divided by 4 is 9 remainder 1. We could say it's 8 remainder 5, but it doesn't make sense to have a remainder that's larger than the number you divided by. Okay, we good so far? You guys excited for this easy test? Will it stay that way? 4. Okay. What can you tell me about this graph before we look at the answers? It's what? It's not positive. Good job. How do we know it's not positive? It's going down. Both sides are going down. What can you tell me about the degree? It's even. Could it be an x squared? No, it has too many wiggles for an x squared. Could it be an x to the 4th? Yes. Could it be an x to the 6th? Yes. It looks like an x to the 4th, but there could be hidden information in there that we just can't see. So we know it's a negative, and at minimum, it's an x to the 4th. It could be larger, but at minimum, it's a negative x to the 4th. Do we know anything else? What does this tell me? It's going to have a double root, so I can actually get rid of one of these and put a squared. Is there anything else I can glean from this? What's that? There is a y-intercept, and in this form, you won't see it. If you wrote it out in standard form, you would be able to identify that the y-intercept was negative. But it won't be visible in this form. Okay. There is one more thing we can do to each of those. So I can put x's in all of those. What can you tell me about this factor? So this one here. It's got to be a plus sign, right? So whatever number is in there, it's positive. I don't know what the number is, so I'm going to call it A. What about the next factor? What about this one? It's also positive. So x plus b. What about the duplicate factor? It's going to be minus. Now, the a's, b's, and c's could be swapped, right? The order of these could be swapped. So another correct answer would be x minus c squared. Let's just put an a there. X minus a squared, x plus b, and x plus c. Those mean exactly the same thing because we don't know what a, b, and c are. Okay, but we do know that the duplicate factor is negative and the two single factors are both positive, right? So all you have to do for this problem is look at the possibilities and figure out which one is correct. Could it be the first one? Could not be the first one. Why? Yeah, it has 4 different possibilities, and the a is positive. Right? So could it be the second one? No, because we don't have any duplicate factors. Could it be the third one? No, there are 2 things wrong with the third one. What's wrong with it? The a is positive, and b and c would need to be positive, and d would need to be negative. So what did you say, the 5th one? Yeah. Nope. 6th one. 1, 2, 3, 4, 5. This one. We need a negative out front, and the squared has to be negative, and the 2 non-squareds need to be positive. And notice here they told us that a, b, c, and d are positive numbers. That way you don't cancel negatives. So that is the only possibility. Okay. What if it looked like this? Let's do it. Hold on. What if it looked like this? What would a possible answer be? Positive a. Good. One of them is squared. And the squared is going to be positive. Like that. Does that problem make sense? Okay, hopefully that's pretty straightforward. All right. Whoa. Did I skip one? No. Oh, we're on 5. Man, we're flying. Find all of the rational zeros. Is that all we have to do? Okay. So what could the rational zeros be? Plus or minus 1, plus or minus 2. What else? 1/3 and 2/3. Okay. Hopefully one of them works. One of the non-fractions works, and then we can factor to find the other 2. Okay. You could do Descartes' rule of signs. Sign change, no sign change. You could fill out that table to kind of give you an idea of do I choose positives or negatives. But really all we have to do is find one. Okay. Does the easy method work in this case? What's the easy method? What's the easiest one to try? 1. Add up the coefficients. Do we get 0? Yes. So 1 works. If 1 doesn't work, then you're just going to have to guess and do something else. How do you test -1? You flip all the odds or flip all the evens and then add them together. So in this case, if we flipped the odds, would it work? It actually would. So -1 is also going to work. So now we know 2 of the answers. So let's do 1. Am I missing any terms? No. So 3, -2, -3, 2. 3, 1, 1, -2, -2, 0. Did I expect that? Yes, I knew it worked. Okay. So if I knew it worked, why did I bother writing it down? Now I have this equation, 3x squared plus x minus 2. I need to factor it. Or, in this case, you know negative 1 works. So you could do synthetic division with negative 1, and that would tell you the remaining root. But if you don't know that, negative 6x squared, are there factors of negative 6 that add to be positive 1? 3 and negative 2. So I pull out a 3x, and I get x plus 1, and this would be x minus 2. So my roots are 1, negative 1, and 2/3. Okay? Now, there is a good chance that it will give you an x to the 4th. How does that change your strategy? You could do Descartes' rule of signs, but you're going to do guesses until you find one that's correct. Then you'll get a new equation. With the new equation, you do guesses until you find another one that's correct, and that will bring you down to an x squared, and you can factor it. If it doesn't factor, then use the quadratic formula. But in this case, it says find all of the rational zeros, and then we have to figure out how they want us to type them in. All right, so list them from smallest to largest. If there are 2 rational zeros, carefully determine the order of the zeros from smallest on the left to largest on the right and enter them in the first 2 boxes and put NA in the last box. If the remaining quadratic does not factor, then put in 1 rational zero and put NA in the other 2 boxes. You guys clear with that? So if you have 3 answers, then write 4, 5, 6. If one of them is a duplicate, then put NA here. If you find one of them, but the remaining quadratic does not factor, then you will put NA like that. Okay, you don't need to find the imaginary or even the irrational roots. You don't need to do any of those. All right. So an x to the 5th graph is shown. Now, that looks like an x to the 3rd graph, right? So there are some hidden zeros inside there, and usually hidden zeros are imaginary, but not always. It is possible to hide zeros that are real. Just not as easy. All right, so use the graph in your understanding concepts of the fundamental theorem of algebra to determine how many rational, irrational, and imaginary zeros there are. Okay, so I told you it is possible to hide roots inside a polynomial, but they have told us that none of them have a multiplicity higher than 3. So there are no hidden real zeros. Okay, so here's what we need to know. Okay, this is created using a single root. This is created using a double root, or it could be an x to the 4th, or an x to the 6th, or an x to the 8th. That's where you hide roots, is inside a bounce. This is a triple root, or it could be an x to the 5th, or an x to the 7th, or an x to the 9th. Okay, those are the only places to hide roots, is in bounces and in saddles. All right, so we know that there are no hidden roots on the x-axis. So if that's the case, how many rational zeros? Okay, this problem's kind of weird. This one's actually really easy. So how many rational zeros does this have? So it hits the x-axis 1 time. How many rational roots are in there? And rational means fraction, so there would be 3, right? So if there are 3 there, what are the other ones? They have to be imaginary. There's no other place to put them. Okay? So this function has 0 irrational zeros, and it has 2 imaginary zeros. All right. So how do I get a new question on the practice? Okay, so I'll just refresh. All right, this is a better question. All righty. Okay. So, is this rational or irrational? Rational is a fraction, so it's somewhere between -2 and -3, but it could be a fraction, right? No. How can I guarantee that that is not a fractional answer? How does that tell me? Yeah. So when I write all possible rationals, my possibles are plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. And I got that from here. What are the possible fractional answers? There aren't any. The leading coefficient is a 1. And if the leading coefficient is a 1, that guarantees that none of the answers are fractions. Okay? So likewise, oh, well. And then the other ones, 1, -1, -1, 1, and 2 are all rational. And there are no hidden roots anywhere. So this is an x to the 5th graph. One, two, three, 4. Oh, 5. Okay, right here. I was confusing myself. So how many rational roots are there? 3. How many irrational roots are there? 2. And how many imaginary roots are there? None, because there are no leftovers, right? We have 5. So if you add up the rational and the irrational and you're short, then you will have imaginary roots, and they always have to come in pairs. Okay, does that make sense? Should be a pretty easy problem. Do you want to see another one? A couple yeses? All right, so leading coefficient of 4. Can this have irrational, or sorry, can it have rational? Let me back up. Can it have fractional answers? Yes, it can. Okay, so what could the fractions be? So 1/2, 1/4, but that's it. And then 2. So we have 1/2 and 1/4 and 2/2 and 2/4. So the only possible fractional answers are 1/2 and 1/4. So this one, and this one are all rational. -1, -1/2, and +1/2. And the others, this one and this one, would be irrational. And this is an x to the 5th, and if I add them up, I have 5. So there are 3 rational, 2 irrational, and no imaginary. If this was an x to the 7th, then there would be 2 imaginary as well. What if it was an x to the 6th? It can't be because of its shape, right? An x to the 6th would be like a triple U. So this could be a 7th or a 9th, but then you would just plug in extra imaginary zeros in there. Okay. All right. Here is a polynomial. We know that, and I don't like how they wrote that. So what do they mean? The I is on the outside, so I like to write it as I root 3. That way you don't get confused. I don't know why they put it the other way. But if I know I root 3 is a root, I also know that negative I root 3 is a root. So x minus I root 3 and x plus I root 3. What's the trick when you multiply these together? What's the shortcut? Skip all the i's except for the last one, the I squared. So x squared, I can skip that one, I can skip that one, but I need this one. And that will be minus I squared times 3. And what is negative I squared times 3? It's just I squared plus 3. What do I do with I squared plus 3? Well, that contains my 2 imaginary roots, so I'm going to divide this by I squared plus 3, and that will leave me my other 2 roots. So x squared, 0x, and 3. X to the 4th, x squared, 0x to the 3rd, 3x squared. Those need to add up to negative 5. Oops, that should be a minus 5x, 0x squared, negative 15x. Okay, those need to add up to negative 2. So I need to subtract 5. And 0x and negative 15x. Those need to add up to negative 15, which they do, and those need to add up to negative 15, which they do. So x squared minus 5x minus 5. Does that factor? No. So we have to use the quadratic formula. So 5 plus or minus the square root of 25 minus 4 times negative 5 is negative 20 times 1. So plus 20 over 2. So 5 plus or minus the square root of 45 over 2. And 45 is 3 times 3 times 5. So we can pull out a 3. 5 plus or minus 3 root 5 over 2. Okay, how does it want us to put the answers? Write all of the zeros in the box between the braces and separate each one with a comma. So I root 3, negative I root 3, 5 plus 3 root 5 over 2, and 5 minus 3 root 5 over 2. Like that. Now, chances are some of you will run into one that will have this. What is the other root if one of them is 4 plus 2 root I? 4 minus 2 root I. or 2i. Okay, and when you multiply these, you're going to get x minus 4 minus 2i, x minus 4 plus 2i. And when you multiply these together, the rule is the same. You can skip every single I except the last one. So x squared minus 4x minus 4x, but this one, this one, this one, this one, all of those are going to cancel, so you can skip them. Oh, I do need the plus 16. And then the last one is going to be negative 4i squared, which turns into plus 4. And then you would do the division. Make sense? Okay. All right. Where is the whole? So we factor. Oh my heavens. X plus 2, x plus 3, and x plus 2, and x plus 4. Is there a whole? Yes. Those cancel, that creates a whole. So the x coordinate of the whole is 2. But what's the y coordinate of the whole? Negative 2. Thank you. What is the y coordinate of the whole? Well, the only difference between this graph and this graph is that in the simplified equation, the whole has been filled. That's the only difference. In fact, if you graph this on your calculator, you won't see a whole. Your calculator is not programmed to show you a whole visually. The only way you can figure out that there is a whole is if you plug in negative 2, and it will say x equals negative 2 and y equals blank. But it won't tell you where the whole is. So to find the whole, we just plug negative 2 into the equation where the whole has been plugged. And that will give us the y coordinate of the whole. So negative 2 plus 3 is 1. And negative 2 plus 4 is 2. So the whole is found at negative 2 comma 1/2. So it's really easy. Find the x coordinate of the whole, and then plug that x value into the equation where the whole has been removed. And that will give you the y coordinate of the whole. Just to refresh, what happens at negative 4? Vertical. So x cannot be negative 4 because there's a vertical asymptote there. What happens at negative 3? It's a root, a 0. Okay. What about HA? Does this have an HA? The top and the bottom have the same strength, so we divide their coefficients and we get an HA of 1. What if the bottom is stronger? Where's the HA? 0. What if the top is stronger? There's no HA. It's a slant or a quadratic or a cube. It just depends on how much bigger it is. All right. Let's graph this. So the top is 5 times x squared minus 4, which becomes x plus 2, and x minus 2, and then x times x plus 3, and x minus 2. All right, what do you know about the graph? At x equals 2, there is a whole. Okay? At x equals 0 and negative 3, we have vertical asymptotes. And we have a root at x equals negative 2. And if you look at the original equation, we have an HA at y equals 0. Everybody follow? Now, let's see if I can put all those on there. Draw a vertical line. So vertical line. I broke it. Dang it. The internet went down. I killed it. No internet. What'd you guys do? No. Okay, well. Yeah.